It's going to be a video covering how to do each of the tests and intervals that we've learned so far in honor stats on the calculator. So to get to all the inference procedures, you got to hit stat and go over to the test menu. So let's start with a one proportion z interval. So that's a one sample z interval for p. So if I scroll down here and I go to a one prop z interval. So to be clear, you are not choosing z interval. You are choosing one prop z interval. Any procedure that involves proportions, it should say prop on the option that you're choosing. So if I hit enter, let's use the example of George being an 80% free throw shooter. So if you remember from that activity, he shot 50 free throws, so that's n, our number of trials, and x is the number of successes. So that would be 34. He made 34 out of 50 free throws, and we want our confidence level to be 95%, which you need to plug in as a decimal 0.95. If I hit calculate, that tells me the 95% confidence interval for George's true free throw percentage is 0.55 to about 0.81. If I wanted to do a hypothesis test, so a one sample z-test for p, I would go down to one prop z-test. The null hypothesis, p0 or p null, is 0.8, so that's thinking that we're assuming, or the claim to be, that George is an 80% free throw shooter, so p equals 0.8. And then, again, what happened with the raw data? He made 34 out of 50 shots. And our alternative is that he is less than an 80% free throw shooter. So we're going to choose the less than P sign there. Don't have to worry about the color, and you can hit calculate. So this tells me that my test stat, the Z test stat, was negative 2.12. And my p-value was about 0.02. So in this case, we would reject, because our p-value was less than 0.05, that George is an 80% free throw shooter, and we have convincing evidence to support that he is less than an 80% free throw shooter. The next procedure would be a one sample t interval for mu. So if we wanted to do a confidence interval to estimate a population mean, I'm going to go down to t interval. You have two options here. You could plug in the raw data using the list functions, but more often than not, I'm just going to give you the stats. So, for instance, let's use the data from or how much sleep honor stat students are getting. So on average, I think our class average was like 7.4 hours. And if I remember right, our sample standard deviation was 0.8 hours. And I think in total, combined with both classes, we had about 27, if I remember right, was our sample size. So our confidence level is 0.95. I hit enter. So this tells us our 95% confidence interval to estimate the true average amount of sleep in hours that honor stat students get, somewhere between about 7.1 and 7.7 hours. If I wanted to do a one sample t-test using the same data, I would choose t-test. And again, data would be the raw data plugging in the list, or if you had the summary stats, you could just use those. So the claim is that honor stat students get 8 hours, but here's our results in the sample. We got 7.4 for our sample mean and a sample standard deviation of 0.8, and our sample size is 27. Again, these options are to describe your alternative hypothesis. I think that honor stat students get less than 8 hours, so I'm going to choose the less than mu option, and I'm going to go down to calculate. Tells me my test stat's about negative 3.9, which means my p-value is extremely small, 3.05 to the negative fourth, so about 0.0003. So we definitely have convincing evidence to support that honor stat students are getting less than 8 hours of sleep in that case. And then moving on to the two sample procedures. So if I did a two proportion scenario, let's use the Mythbusters data. If I go down to two proportion z interval, if you remember right, 10 out of the 34 individuals who got a yawn seed yawned, and then 4 out of 16 in the control group yawned. So our interval, if we capture that, goes from negative 0.22 to about 0.31. So the fact that this interval captures 0 kind of suggests that there really doesn't seem to be a difference in the proportion of people that yawn if they receive the yawn seed or if they're in the control group. If we want to further check that, specifically with the hypothesis test, we would choose a two prop z-test. And there's our data again. And we want to choose less than, or actually greater than, sorry. we're going to try to see if the yawn group is yawning more, has a higher proportion of people that yawn if you're given a yawn seed instead of the control group. And I go down to calculate, and you see our test stats about 0.32. Our p-value is really high, 0.37, so that tells us our evidence is not very convincing. So we would fail to reject the null hypothesis, and we do not have convincing evidence to support that a yawn seed actually improves or increases the proportion of people who yawn. So we don't really have evidence that yawning is contagious. Okay, and then our next one was the data that we used in class today, which was looking at the average number of vaccinations per day from a couple 35-day spans in Oregon. So this would be, again, if we go to stat tests, this would be a 2-sample, and we don't know sigma. We're using SX to estimate them. So we're going to do 2-sample T interval. For our stats, our first, from the most recent 35 days, the average number of hospitalizations was 18.6, and the standard deviation was 6.4 for that sample of 35 days, so our sample size is 35. And then for the next the next 35 days before then, our hospitalizations were much higher at 36.4 per day, and our standard deviation was 7.2. And again, that was a 35-day span. Confidence level is 0.95 or 95%, and we're not pooling in this case. So hit calculate, and our interval is from about -21 to -14. And then you notice this is the key thing, it gives us our degrees of freedom is 67. That's the main reason we need to run this on the calculator. And then if I did a hypothesis test with the same data, if I go stat, go over to test, and I want to do a 2-sample t-test, I go to 4, and then again, our first X bar was 18.6, first standard deviation of the sample was 6.4, sample size is 35. Second sample mean was 36.4 with the standard deviation of 7.2 and a sample size of also 35. And let's say we're trying to find evidence that the most recent 35 days, the average number of hospitalizations is less than the average number of hospitalizations for the 35 days before then, right? So we saw our sample means decrease, so our alternative hypothesis, we're trying to find some evidence that essentially there's been, on average, less hospitalizations per day in Oregon as time has gone on. We don't want to pool, and we go down to calculate. So if you notice, our test stat is massive, -10.9. P-value is basically 0. So this data suggests pretty much without question that the average number of hospitalizations are decreasing in Oregon over the last 70 days, comparing the last 35 days with 36 days ago up to 70 days ago. I hope this video was helpful in terms of kind of how to break down and use the tests. Other tests that we'll be looking at in the future, I'll make future videos for, will be chi-squared test and chi-squared goodness of fit test, which we just haven't got to yet. Thank you.